We'll go through that. Okay, I think we're good. We're good. Afternoon, gentlemen. How are you?
Good. Okay.
Good. Yes. Good. Thank you very much. Not too bad at all. So welcome back, everybody. Following on from last week, 2 weeks ago now, I think actually streamed. So we're going to kick off today with Ian, who's going to be going through computational thinking and coding, and then we're going to move on to Luke, who is going to be taking us through some working examples using some of the resources available online. So Ian, we're going to hand straight over to you, and then carry on.
Thank you very much. Okay, so I'm just going to be talking about computational thinking. It's something we've had quite a few questions about actually what is computational thinking. So I'm going to be looking mainly at Key Stage 2, but the same messages can apply in foundation phase as well. So what exactly is computational thinking? So people tend to get it mixed up with coding, and it's not the same thing. It's really important that we realise the difference between computational thinking and coding. So let's start off with computational thinking. So computational thinking is all of the background information and skills that you need to solve a problem. So I give you a technical problem that I want to solve. Computational thinking is about breaking down that problem, looking at what you've got to do, and that's called decomposition, and looking at the process you need to solve it. And that's essentially what computational thinking is. So coding is the actual writing a program, exactly telling the computer exactly what to do. It's much more the nitty-gritty of that creating a program, whereas computational thinking is all the background thinking that happens beforehand.
I'm going to stop you a second because I don't think it's working.
Okay, hi guys. So I'm going to be talking to you about exactly what is computational thinking and the difference between coding. So very often when people talk about computational thinking, they get it confused with coding. They think of writing programs, writing websites, things like that. So computational thinking is all the background thinking that you do around when solving a task or solving a problem, such as analysing the data and using skills such as decomposition to break down a task. Thinking about that step-by-step process. How do you solve a problem, what process you're going to follow, what steps you're going to take. And that's essentially what computational thinking is. Whereas the coding is where you're telling the computer exactly what to do. You're actually writing a computer program and you're giving it those step-by-step instructions. So the coding is actually writing a program, whereas the computational thinking is much higher level, thinking about how to solve the problems, what steps you've got to take. So looking at actually the digital competence framework, computational thinking is in there, it's a big part of it. So I've got here the year 5 skills, and it's looking about how processes run, putting things in order, looking at algorithms, and understanding if I change certain parts of a process that it'll change. Actually coding isn't mentioned anywhere in the digital competence framework as it stands. So these are the main messages really, that what people have to do is there's the Scratch Codo, no programming language is mentioned at all in the primary digital competence framework. Those sort of terms only really start to appear when you get to Key Stage 3. It doesn't mean you shouldn't code, and that's really important. You know, we want to push the boundaries of technology, and coding will definitely come in when the other areas of learning are written. So it's really important that schools, if they are doing coding, don't abandon it. But what it's important is that we realise the difference between that and the computational thinking. So it doesn't mean you have to use things like Scratch, Codo and programming languages, but I would advise that you do, because we want to prepare these children for the future. So this is how I'd think about Key Stage 2. If I was doing a maths activity, I'd start off by learning mental methods. I'd look at practical rehearsals. I then get the children to describe their methods to me, and then off we go, we do it. And it's very similar sort of steps you take with computational thinking. You know, I'm looking at doing coding or writing a virtual program. Some people tend to jump straight to the end, where actually they need to do a lot of steps beforehand. You know, I need to practice those practical skills first of all. I need to practice them and debug them. I need to write algorithms, and I need to do it virtually and actually implement it. So we can look at how this actually works in the classroom. So I always start with an unplugged activity, and I mentioned the one in foundation phase last time, which was writing instructions for how to make a cup of squash. Did this with Key Stage 2 this week, and it was hilarious. You know, do they tell you when to stop pouring the water? Do they tell you when to stop pouring the squash? It's a lovely one. Another one to do is instructions, so getting the children to direct each other from one end of the yard to another around an obstacle course, sort of like B-bots but in real life. So that's a great unplugged activity to get them thinking about those processes, and I'd start to then get them thinking about how to record them. So they should be recording all of these directions, everything that they do. It's not just a playing activity, they're actually doing it for a purpose. For instance, Lidway Primary School asked us where we can get a bank of unplugged activities. Well, literally, if you go onto Hub and you search on the resources for unplugged, absolutely loads come up. The majority of them are for Key Stage 2, but actually these barefoot resources, but actually they can be easily adapted to foundation phase or Key Stage 3. So if you want an idea of how to start these sorts of computational thinking activities, just search for unplugged on Hub and there's absolutely loads. So then we need to think about debugging and actually using that phrase with the children, that right, you've got a problem with your code. For instance, this little girl, she's got stuck behind the drain pipe. So we've got a bug in our program here because the instructions haven't worked. So we need to debug it, we need to write the code again, we need to edit it, and we need to try it again. And getting the children to see it's not about getting from one place to the other straight away, it's about that debugging, it's about trying again and seeing how it works. And then we can look at moving on to the virtual. So we've done all this practical build-up, they've used this problem solving, they've written these steps, they've debugged as well, and then looking at apps to move on to the virtual. Now, one of my favourite ones is Alex Robot, and it's free. And looking at, all you have to do very simply is get the robot from one end to the other. But when we're doing this, you know, you've got to be very careful that it doesn't turn into a room of children playing. So where are you recording these? You know, the children should be recording their answers somewhere. But also thinking about the numeracy, using language such as clockwise, anti-clockwise, 90 degrees, right angles, and also what language is developed, thinking about left and right and the clear instructions that they're given to others. So that's a really nice one, Alex. So another one is Lightbots. You can get this for the iPad and on Android, but it's also available online and it's free. And so I'll just show you a little demonstration of how it works. So very, very simply how Lightbot works. You have to get the little robot and programming, and you've got to get him to the blue tiles and turn on the light. So I'm just going to show how that simple program works, and I've completed my program. But when that's quite simple. So what you can do is go into more complex procedures, and this is really where it starts to turn into coding. But all of those qualities that I developed and those skills that I developed in the computational thinking are coming in here, because I've got to plan it out, I've got to debug if it doesn't work, and I should be using that language actually through it. Now, Lightbot is more suitable for Key Stage 2. It does get quite complex, and so this is a really good one to really stretch, particularly when you get to the higher levels, your top ability. So that's some way there. Now, that is lots of activities to develop that computational thinking, but one question that often comes up is, what exactly is an algorithm? And it's a word that scares some people, but it actually is very simple. It's a set of instructions. And I don't know if any of you ever watched The Big Bang Theory. It's one of my favourite comedies, and there was a brilliant algorithm on here called the friendship algorithm, which Sheldon Cooper wrote about the instructions of how to make a friend. And I'd be intrigued to see what children would come up with this. But this is essentially quite a complex algorithm, and we wouldn't be expecting to see anything near this complex in Key Stage 2. This is what we'd be looking to see, and this is our Year 6s did this, and we had a summer fair coming up, and our Year 6s went into the town and they needed to ask for prizes off shops. So they wrote an algorithm for what they were going to say in the shops. So for instance, given the school name and purpose, it's quite linear here. Moving down then to would you be interested? Well, yes, no and maybe. Depending on what the answers were, they went to different places. And actually the Year 6 teacher commented she could do this with so many different discussion points in English and ways of getting the children to really structure the discussions. But that is all an algorithm is. It's a flowchart. It's thinking about what do I do at each step. In lower Key Stage 2 in Year 5, you'd just be expecting a linear chart going down. It's only really, you know, the end of Year 5, maybe going into Year 6, you'd be expecting to see it branching off. So for this activity, I used a website called draw.io, and it's a free website. and it's simply a drag and drop interface that you can use to create a flowchart. And we didn't give any help to the Year 6 children at all. They worked it out. You might notice it's very, very similar layout to Google Docs. It's created by Google, and you simply drag and drop in the different boxes to create the flowchart. It's as simple as that. So there's some activities for you on how to do computational thinking and the differences between that and coding. So I'm going to pass you over now to Luke, who's going to be taking you through some actual coding work.
How you doing? I'm slightly taller than Ian, so I'm going to
thanks, Luke.
tilt the webcam back. Probably quite nice. You're looking directly up my nose now, so that's a real treat for your watching. Yeah, as Ian said, we're going to look at a couple of examples of coding. Now, one of the most popular things to use for coding is Scratch, used everywhere, which is a drag and drop coding platform. And I know lots of schools will already be familiar with Scratch and how to use Scratch, so if you are one of those schools, then I apologise now. On Hub there are also some fantastic things to teach coding, and I'm going to start with something that I used when actually I was in primary school. I'm just going to jump back into Hub Tools for a second and go to Just Too Easy, because if you have a look down the bottom, where is it? Oh, the top, sorry. Different on mine. If you have a look there, you've got these programs here which are absolutely fantastic. You've got the JIT coding platform, which is great for foundation phase, looking at just directions. Lots of you will be familiar with BBots and using BBots for directions, and this is a very, very simple program. You can see here you've got the little spaceship sprite, it's called in Scratch, but the little spaceship object, and then you've got these little arrows here, and as you record the different directions, you can see on the right hand side of the screen, you can say if the rocket wanted to travel to the sun, you can navigate the rocket around. You can see it records the instructions there, which are the great. It is so simple to use with foundation phase children and to navigate that around, but then you can also create problems for them to debug as well, like Ian said. So if you wanted the rocket to go to the moon, you could ask them how they get to the moon, and you can simulate those activities using your Scratch turtles or BBots as well, sorry. You've also got the visual coding platform, which is very, very similar to Scratch in that you've got a stage and a sprite and drag and drop blocks, which are very similar to Scratch, and there are also some projects ready made for you to follow in there. But the one I'm going to start with, which is, as I say, something that I used when I was in primary school, is the Logo coding platform. I absolutely love Logo, and wonderful for teaching angles and shapes as well, 2D shapes. And so I'll just start. This is going to be a whistle-stop talk because I'm not sure how long I've got, Andy, but I'm going to start very simply with the most basic of commands, and there are some arrows up there, and there are different levels if you want to go through to the other levels as well, which give you the other window, but I'll come on to that shortly. So I'm just going to start off by showing you how to go forward and backwards. So Logo works with little commands. So if I say FD100, you can see the little turtle or arrow goes 100. Then RT is a right turn, so I'm going to right turn 90. I'm then going to do another forward FD100. You've got to put a space in the middle of the command as well between the distance. Another RT90, and then FD100. RT90, another FD100, and you can see I've made a square. Now that square at the moment is 100 by 100, and I think it's probably pixels, but you can draw shapes of different sizes. The next challenge is to try and get them to draw a rectangle, and so on and so on. If you want to clear the screen, you just do CS, which stands for clear screen, and again, if you Google Logo commands, you'll probably find, and PDF, you'll probably find a whole sheet of different Logo commands that you can use. So the next thing you ought to do is teach the children how to make things simple. Computers like things really simple and efficient. The more complex a program is, the more processing power it takes, and ultimately you want to try and make your code as efficient as possible. So computers like it when we loop commands. Therefore, if we're drawing a square, what I effectively did then was 4 lots of the same command, FD100 RT90. So what I can do is actually start to repeat commands. So if I repeat 4 times and then put in square brackets FD100 and then RT90 what I've actually done there is told the computer to repeat what's in the square brackets 4 times, and in the square brackets I've got FD100 RT90. You can see as I push run or execute the program, try to use the terminology with children as well. Execute is when you run a program. You can see the turtle draws a square. Now we can actually take that one step further, because okay, if I want to draw other shapes, I can ask the children to draw a triangle, which is always an interesting one to see whether they can solve the angles in a triangle. And a circle is another interesting one as well, because there's that question: is there such a perfect circle? Because how many degrees are you rotating by to actually get the computer to draw your circle? And there are a whole load of challenges. Look up if you do a Google search for Techno Camps and logo. You'll probably find their logo workbook, which is fantastic, and I'll see if I can tweet a link to it later on as well, because it's quite a great tool for working through some of these problems. And it doesn't give children all the answers, it simply just sets up the problem and they can solve it by themselves. So if you want to use that square that you've drawn, and let's say you were building something bigger, for example, if you were to draw a picture of a house, you might use 4 squares for different windows. So I'm going to just clear the screen. I'm going to go on to one of these levels, and I can actually create a program. Now Ian talked about Lightbot, and you can actually create procedures that you can call into a main program. So I'm going to create a procedure called square, and you do that just by writing to and then give that a name. I could actually call it anything. I could call it to Luke or to Andy, but it's helpful if you know what your procedure is. So this is going to be the procedure for a square, and then if I just put what I wrote before, repeat for FD100 RT90, and then I need to end at the end, tell the computer that that's the end of my program. When I execute that, what that actually allows me to do is, rather than typing in any commands, I could just type in square, if I could spell it, S-Q-U-A-R-E, and that will actually draw your square. It will pull your procedure in. So you can then do some crazy patterns if you want, because you could write square and then rotate the turtle slightly and draw another square. So if I RT10 now and draw another square, you can see it draws another square of 100, and it will. I could make it actually rotate that all the way around to create a wonderful little pattern. You can then go on to talking about variables, and you could define that. Instead of putting 100, you could call it square and use a variable in there. So rather than drawing a square of 100, you could actually put your variable, you give your variable a title and put that in there, and if you were to type in then square 20 or square 50 or square 80, it will then draw a square of those relevant sizes. So yeah, that's a very whistle-stop tour of how to use logo, and right from starting off with just one line basic commands into repetition and then to call in procedures. I'll try to tweet a link later on with some further instructions, because anybody who wants to take that further, you can do some incredibly basic but also incredibly complex stuff as well. I'm going to go. Am I okay for time, Andy? So I'm going to just talk very quickly about Scratch, probably one of the most commonly used things that primary schools and secondary schools actually use, and people like it because it's a drag and drop programming thing. In other words, you don't necessarily need to learn a computer language. Computers have lots of different languages, all used for different things. You've got HTML specifically used for decorating things, and more recently HTML5 to be able to control things and animate things even on screen. And actually, one of the most basic of those things to use is just Scratch drag and drop, because although that doesn't teach you a specific language, it teaches you the concept of being able to do what I just said in looping procedures and looping things to make efficient code, and it's just nice and easy for children to see. The other great thing to do with Scratch is when you've dragged all your blocks over and created a program, it's often really important and useful to get the children to actually talk you through what their program does and what each block does to their program. So I'm just going to come across, as I said, that J2 visual on J2 code is pretty much exactly the same as Scratch, but I'm just going to jump to Scratch only because I'm more familiar with using it. And the one thing I'm going to show you, one of the most fantastic resources, as Ian said, there are so many people wanting to help with coding. You've got all the barefoot computing resources. If you do a little Google for barefoot computing resources, or look in Hub, you can find them bilingually as well, I think. Techno camps have also released a whole load of booklets and workbooks to support pupils with solving problems through computational thinking and coding. Also Code Club. Now you can sign up to Code Club for free. Sorry, I'm just typing code, not Code Club. You can sign up to Code Club for free, but you don't actually even need to sign up. It is wonderful, and if you want to start a Code Club in your school, everything is done for you. It's literally so easy. You just log into the website and it will give you the projects, and you just work through week by week, or however often you run your Code Club. It will show you week by week different activities for the children to follow. If you just go to the website and click projects, however, there are some projects that you don't even need to be logged in to access, and you can see down here the Scratch projects. There are a whole load of really simple and basic Scratch projects, and if I show you this Lost in Space one very quickly, it's pretty much all done for you. Andy appears not to have Flash installed on his computer, but it doesn't matter, because you can just see as you scroll down, that little Flash window is actually just a sample of the program that you can create. So let's say you're doing Earth and Space or something in school, you're looking for a relevant activity that you want to teach a bit of coding, or dabble with a bit of coding if you haven't gone there before. You can literally just follow each of these instructions. So start a new Scratch project. So back on Scratch, if you just go to the try it out screen, again you can sign up to Scratch, and if you want to create a whole load of different users on Scratch, it will allow you to do that as well, although you just need to tick a box to say you've given parental consent and all the children have got consent to be able to use it, but you can create multiple users at once. You'll automatically be greeted by this window when you log in. You've got your stage over here on the left, you've got your sprites window down in the bottom left, your different blocks in the middle, and over on the right here there is a little kind of tutorial to get you going. You can create these little projects, so if you're just having a play with Scratch and haven't really used it before, I'd recommend you have a little go at using that to begin with, and just try to follow through some of the problems on there. Otherwise, this is the little area where we drag our commands. So I'm just going to go back and forth between the two windows and follow it step by step for you. So you can create a new Scratch project, so I can tick the box, and the nice thing is the children just can tick through the steps as they go through the project, the great thing about coding, it's the one time where if children ask a question, the best answer is get them to problem solve and persevere, and use all of those wonderful learning power skills that they acquire, because you don't want to just come over and give them the answer every time. It's so important that children develop their problem solving skills through this, and as my good friend Sunny Singh once said, when questioned if computational thinking and coding is really important for all learners, somebody asked him, is it really important that we have a nation of coders? We don't need a nation of coders, and Sunny replied, no, but we do need a nation of thinkers, and I think that's the crucial thing, that problem solving skills are developed here when we look at coding, and so don't just give pupils the answer when they start to struggle. Get them to have a little play until they've worked it out, because they'll feel much more pleased with themselves by the end of it. Okay, so then we're going to do the next thing, add a spaceship and Earth sprite. So I'm going to tick that box and just go ahead and do that. I'm going to delete that current sprite by doing a right click and clicking delete. Then I need to make my new sprite. These little buttons up here create a new sprite. If you've got a picture that you want to use on your own computer, you can. If you want to paint your own, you can draw your own little sprite, or there's a wonderful online library of all these things here that you can jump to, and I'm just going to go ahead and find the spaceship that they'd used and insert that sprite, and I'm going to add another sprite which was the Earth, and where's the space thing? There it is. So I'm going to put the Earth in, and I'm going to put that at the top right of the screen. You just drag and drop where you want to position them on screen for the start. The other thing that you need to be able to do is to set your stage. Now the stage is basically another name for the background, and if you click that little picture down at the bottom right, again it will give you a range of different backgrounds that you can use. You can paint your own, or you can open your own. So I've made my Scratch project like this. I'm having a sign in front of me at the moment that says 5 minutes, so I'm not going to be able to program the entire thing through, but you get the general gist. So once you've created your spaceship, you can go through, and it wants you to adjust how the spaceship is and rotate it on its side. If you want to edit anything about your spaceship, you can see, you just click it and it will open up in this little editor here, and if you want to rotate it around, you just rotate it around to the right like that, So very simple, the children pick it up with ease really, and then go back to your scripts, and you can add certain commands to your sprite that you've got in there. For example, if I go to events, I say when the green flag is clicked, so that's how most computer games are start. Something has to happen for it to begin, and again, if you just follow through the instructions, it gives you the first bit of code to go through, so you can just basically copy the starting code. And then the great thing and the fascinating thing to watch children is how they use what's already there, but immediately pupils will start to say, well, instead of saying let's go, I want mine to say let's go Tom, or let's go Adam, or can I make it play a sound? I've noticed that there's a sound control option. Can I make it play a sound as I go? So yeah, it's as easy as that. I'm not going to talk you through the entire program, because this, if you go to the Code Club projects, it will talk you through pretty much everything, and what you end up with is a little animation where a rocket ship, when you push the green button, the rocket ship flies up towards the Earth, and the children have to do things. It doesn't fly all the way, I think, to start with, so they've got to edit one of the parameters. If you go back to the program, you have to edit one of the parameters to change the distance of how far it flies. It shows you also how to put a gliding monkey floating across the screen with as an astronaut, and all sorts of clever things. That's one of the really easy projects. But computer games, I love playing computer games, and there are some fantastic things that you can create. And one of the things I know that Tom Crick said at the start in his initial report to Welsh Government before the review of the curriculum is that we need to teach pupils not only to be consumers of technology, but also how to create it as well. And so Scratch is certainly one of the most amazing tools that will engage pupils, particularly boys, when you start making computer games. But it teaches them not only to be consumers of it, but to create it as well. I know that probably has been an incredibly fast whistle-stop tour of those two platforms, but follow Code Club through, and any problems, tweet Andy at the EAS, and he would love to come out and do some training with you, or broker some training for you on how to use those platforms.
Is the other camera going to work?
No.
We're going to finish off with Luke's face because the other camera isn't working. Well, Luke and Ian, they're both there. Guys, I hope you found that useful. Luke and Ian, thank you very much for what you've done. Here I am, yes. Thank you very much for what you've done today. If you've got any more questions yet, please get in touch. I know that Ian's just put on one of the question blogs his Twitter handle. Luke's is out there as well, and via the EAS Twitter handle you can get in contact with everybody as well. Just a little reminder as well of the some of the latest tools that have been released. So the self-audit tool, which is in Hub, you can get that. There's the curriculum mapping tool, an absolute must if you haven't started mapping the curriculum, the DCF across your school, plus the huge amount of resources that exist within Hub. Alright folks, thank you ever so much for tuning in. Thank you very much to Luke and to Luke and Ian in particular for a training session today. If you've got any suggestions for what you'd like to see next time, please let us know. I think am I right in saying we've just booked in the 18th of September?
Yeah.
Yep, so next session is going to be the 18th of September now. In between that, have a lovely summer holiday and we'll speak to you soon.